So today we are going to be working on the Lunar Orbit and Phases Lab. It is on page 89 in your lab manual, so make sure you have that open at this time. And what I thought I'd do is spend a little time introducing the lab and also getting you started on the understanding how to read the moon phase diagram on page 90. So I thought I'd take a minute to read the short little paragraph that we have here just to kind of get us ready and going in this lab. An observer can only see 50% of the moon's entire surface. And we are going to learn that the reason why we only ever see 50% of the moon is that the moon is moving around the Earth at the same rate that the moon is rotating on its axis. So as it's moving around, it's rotating at the same speed, and therefore we only actually see one particular side of the moon. However, an additional 9% can be seen from time to time around the edge because of the relative motion called libration. Libration is a slow rocking back and forth of the face of the moon as viewed from Earth. And one revolution of the moon around the Earth takes a little over 27 days and 8 hours. That information you can actually find in your ESRT, page 15. When you see that, you will see the period of rotation and revolution for the moon is 27.3 days. Important number, but that is how long it takes the moon to go from one point in the orbit to the exact same spot in its orbit around the Earth. And remember that moon's orbit is also an ellipse, just like the moon's orbit and all the other planets in our solar system. The moon rotates on its axis at the same period of time, so the same face of the moon is always presented to the Earth. Very important part. You're going to need that later. Over a period a little longer than 29 and a third day, the moon goes through phases. These phases cause the light part of the moon that we see from Earth to appear to change. The phases are caused by the changing angle of the sun hitting the moon. And so this number right here is also very important. To go through phases, it takes 29 and a half days. So what you have are two different numbers. Both are really important, however, both can be mixed up. So I want you guys to remember that you can go to your Earth Science Reference Table to figure out the period of revolution for the moon. But when it comes to a full set of phases, we want to remember that it takes about a month. So think of a month. And that's how long it takes, about 30 days, to go through a full set of phases. All right, now that we have read the short little paragraph, let's turn to page 90 and start learning how to use the moon phase diagram. All right, so everyone should be looking at page 90. And I'm going to go over how to read this, what we call the moon diagram. Very popular Regents question, very popular diagram to have and be asking you all different kinds of questions. But really how you can use this to your advantage and how you can use it to help you answer something like this down below, which is, what is the moon phase if I'm on Earth, if I'm standing on Earth. So let me stand on Earth for a minute. And I look up at the moon at position 1, what would be the phase that I see from my perspective standing on Earth looking up at the moon. So in order to answer a question like this, one of the suggestions that you have in this procedure on this lab, and also what I would suggest, is you want to see how there's an arrow? You want to run it through, and you want to connect your two arrows through the moon in position 1. What you're doing is you're showing this side of the moon that you're actually seeing and viewing from Earth. So if you're standing on Earth looking up, you would only see this portion, and from our perspective, it is all darkened in, it's all black. So if I come down here to this position 1, this is what I'm going to draw because this is what I would see. We call that new moon, which I'm sure everyone's yelling out right now. So that's what we would see. So again, here on the top portion is an aerial view of the Earth moon. You're out somewhere out in space looking back down at it. And you're then trying to switch your perspective and say, okay, well, if I'm standing on Earth, what would I see if the moon was at that position 1? So it's asking you to visualize and try to figure out what you would see. So this is what my little strategy is for you guys. So move over to position 2, do the same strategy, put my line through it. Let me change the color to red so you can see it. So put my line through. And so now this is what I would see when I'm standing on Earth looking up at the moon. I'd see a little tiny crescent over here on the right. So I come down here and I would draw my little crescent of light and color the rest in dark. And because the light is on right, what is it again? I'm sure again everyone's yelling out waxing. So remember, light on right, it's waxing. So this is our waxing crescent. And you're going to take a moment now and you're going to go through and do position 3, position 4, 5, and all the way around. So if you would do that, the teacher will stop the video. I would like you guys to do exactly what I was doing, my strategies for 1 and 2, and fill in the rest of this. And when she turns it back on, there will be the answers for you so you can check your work. All right, so how are we doing? Hopefully at this point you're checking and you see that we match our answers. And if not, make any of those changes. And if you did, great job. But this is the moon phase diagram. So what we're going to do now is you're going to take the time, finish the rest of the questions. There's questions on page 91, and then there's multiple choice Regents questions at the end to wrap up this lab. This should be done by the end of the period. And you can put it right back in the basket and I will check it later. Good luck.